Let's try drawing some Lewis structures out for something like SO2Cl2. If we think about our valence electron count, 6 plus 2 times 6 plus 2 times 7, so that's 14, 24, 25, 26, 27, 28, 29, 30, 31, 32, which is going to look very familiar to some of you as a typical tetrahedral shape. So the one that likes to make the most bonds is generally the one that goes in the center, so that could be sulfur or oxygen. They both like to make 2 bonds each. Sulfur's less electronegative, so generally we would think about him going in the middle, which would give us a structure that looks something like this, which is a perfectly acceptable structure. It is definitely one of the resonance possibilities. However, it's not necessarily the best one. And in order to figure out why, let's look at our formal charges. So sulfur has 6 valence electrons, 5, 4, 3, 2. That's a +2 formal charge on the center. 7, 6, 5, 4, 3, 2, 1, 0. Each of these would have 0. And 6, 5, 4, 3, 2, 1, 0, -1, each oxygen would wind up with a formal charge of -1. Now, because sulfur is beyond the second row, it can actually have an expanded octet, which means that we could put some double bonds in, which might actually help things out. Keep in mind, oxygen really does like to have 2 each, so we could move some electrons around. Still have our 32 electrons allowed, but wind up with something that looks more like this, which is completely crazy when you think about what we would usually expect from our Chem 1 understanding. But when we actually calculate our formal charges now, 6, 5, 4, 3, 2, 1, 0, the chlorines are the same as they were before, so that's 0, and the oxygens, 6, 5, 4, 3, 2, 1, 0. We actually wind up with a resonance structure that has all zeros as formal charges, which means it is definitely our better bet. Now, on the way to get there, we also may have considered just putting a double bond on one of the 2 oxygens. Still 32 electrons. But now we do maintain 6, 5, 4, 3, 2, 1, a +1 here, and a -1 there. Which means it wasn't necessarily as good as the one we wound up with. Try pausing the video here and do this same type of calculation. This time, let's try using something that we're kind of familiar with. Let's look at something like phosphate, PO4 with a -3 charge.